This talk is about smart contract auditing, and well, some reflections I can give after 3 years auditing with our team at TXPipe. So this will be like, it's my first talk related to auditing in Cardano. I think it will be very basic, but there's a lot of things like I think I would like to talk about, because sometimes I have the feeling that there are some misconceptions or disagreement about what auditing is, and this is after the experience we had working with a lot of projects. So I will present the team, discuss a bit about what is auditing for us, also talk about software engineering. That is like something I like a lot, and I talk about it all the time. And it will be not technical at all. This talk will be more like philosophical and, well, high-level conversation. That's more or less. I also expect to have some time to discuss with you what do you think about these ideas. Okay. So first, a bit of history. We've been auditing for TXPipe since 2023. And well, we did a lot of work on auditing. We read a lot of source code, a lot of Icon, a lot of Haskell, projects of any kind. And well, you can see there some basic numbers, like a lot of findings, and well, a good number of critical findings. This is like the core auditing team we have right now. Ale, me, Valentino, and Ignacio, they are all here with me. But well, we are also a much bigger team with a lot of people that is somehow also involved in the process. Like, well, Lucas and Kay said that they were like the ones that started auditing at TXPipe, and we are like we are receiving the legacy of them. Fede Almano that work a lot on quoting and selling our service. People that we are onboarding for auditing, because we are having now a lot of demand. So we are onboarding new people like Pedro and Agus. Agus is here also. And there are also some like complementary activities we are doing to improve our auditing process. And for that, we are starting to work also in formal methods and trying to use them for auditing, and developing a lot of tools to assist in the task of auditing. So there we have Felipe, we have Marco, Santi, of course, Nico, Sara, Fran, Sophie, the other Fran, Lola, etc. A lot of people that is more or less related to improving our auditing service. So I will try to explain briefly how do we audit. Okay, I would say like it's a 3-step process at a high level, and these are the 3 steps. So I get into the first one, that is the work on the protocol specification. This is the first task we do when we do auditings, and it has to do with deeply understanding what is the protocol about and how does it work. Okay. And we have like a deliverable that is the first part of our audit report. That is the protocol specification. And in this specification, we have a somehow like semi-structured language and procedure to describe the protocols, where we have some sections devoted to explaining which utexos are part of the protocol, with their values and datums, which assets, which policies, and of course, and the most important part for us, the transactions that are part of the protocol that can be performed. And also, we use a lot of diagrams to describe these behaviors we expect to have in the protocol. Okay, so this is like the first big part of auditing, is to having this specification. Next part, I think, is what most people understand as doing the proper auditing. That is like reading the code like crazy, line by line, and trying to find there some bugs and vulnerabilities whatever. Of course, this is a very hard work. We have like to do a lot of annotation to try to keep it an active work, because if it is only about reading code, it's like very boring and you can miss a lot of things. So we also try to work a lot in pairs or with discussing the possible vulnerabilities with other people. And well, here I describe like the main flow we do when we find some possible issue. When we find an issue, we usually have like a permanent channel of communication with the development team. So we communicate immediately when we have this suspicious finding to the team. We may confirm it or not. This is like the happy path where we do confirm the finding. And we also have to like settle the severity of it. Sometimes it's like a kind of a negotiation with the dev team. We feel it is critical, they think it is a minor, and well, we maybe end up saying it is a major. But we do like to discuss it, and it's usually a honest discussion. And sometimes we realize we were like giving it like a severity that was too high, or the other way around. Sometimes the customer understands that it is more severe than they were thinking. Well, that's more or less the process. And when we finish doing this iterative process of reporting findings and working with the development team on the resolution of the findings, is the finalization of the report, where we like end up doing all the bureaucracy around the report, the overview, the commits that are being covered by our audit, and a lot of other things. But it's a good moment to like talk about the template we're using. It's a template that we are now we have it publicly available at our GitHub organization. So if you want to do auditing, you can also base your audits or your reports on this template. And it's like the idea, I think it was originally a proposal by Lucas and Casey, is this idea of auditing as code, where we also do like version tracking of the report itself, and the report is like source code written in this language called types, and it can be compiled to a PDF or even to some other format. So that's more or less the process. A highlight about what we do. We have formally defined as possible severities. We have these 4 levels: is critical, major, minor, and info. These definitions are kind of legacy also, but I think that there are some problems with these definitions. What I want to highlight here is that I think they are all centered on talking about actual vulnerabilities or bugs in the code, and very centered on the source code. So all the definitions are around that. And regarding info, well, they say the definition says that info are not actually issues. So we will see if we are in our practice using like these definitions literally or not. So this is the philosophical moment, or the moment to start to reflect a bit. Here is a first take on a definition of what is an audit, and it's a bit, it comes a bit also from ChatGPT, but ChatGPT can do better than this. It says if you ask for a short sentence, you get something like this, okay? And here it says a systematic code review to find vulnerabilities and bugs. Okay, so starting from here, I would ask this question: what are vulnerabilities? What are bugs? And also, is if an audit is only about that, or if there is something else. Okay. Also, something we could ask is if auditing is only about reviewing code or something else. So let's think a bit about what are vulnerabilities and bugs. This is like a graphical description of what a validator is. It's like a division of the world between something that is accepted and something that is not. Okay, a validator returns true when the action is like accepted, and it returns false when you cannot perform it. And well, maybe I can read a validator, the source code of it, and come up with this picture, okay? How do I know if some points here are okay or they are bad? What I need actually is to know what is the expected behavior, okay? It's like what it should be, not what it is. So in the intersection between these two plots is where we can find the actual issues, the bugs and the vulnerabilities. Sometimes, like a validator will return false, but it should be returning true, like in the A point here. And sometimes it will be the other way around. It will be returning true, and it should be returning false. This is an example of a vulnerability like this is at some point where some funds can be stolen by someone that shouldn't be having access to that funds. There is another axis here. So the thing is, what is the distinction? This is all vulnerabilities, but also bugs. Both answer to this behavior. I would say that the only difference between vulnerabilities and bugs is that vulnerabilities are a kind of bug that can be exploited by someone to get some benefit or to do some harm to your protocol or to the people using it. That's more or less how we want to find vulnerabilities and bugs, but the problem is that to be able to do that, we don't only need the code, we need to have this other picture, the expected behavior. So where do we take this from? If we want to do good auditing, we need as precise as possible this picture, and to have this, we need access to a lot of other documents that are not only the source code, but are related with the previous processes of creating a protocol and its implementation. For instance, requirement documents, white papers, specifications of the business logic, etc. A lot of information we need, and then we usually struggle to get them from at the time we want to audit. So it's something that I wanted to mention here in the talk, and something that I want to push, and we always push all the projects to have. Okay, this kind of precise descriptions of their protocols. Well, so the definition of vulnerabilities and bugs is more or less understood, or at least my view about it. And what about other possible aspects of software that are not necessarily vulnerabilities and bugs? There is a long list here. The ordering is only to have a nice shape, triangular shape, not logical at all. But well, let's talk about them quickly, okay? So the first one is minimal quality standard for software, okay? This is applies to any software piece. You need to have a basic checklist that your project should be accomplishing, and sometimes it doesn't happen. Sometimes it's not very bad, it's okay, it's just a bit more of work. A lot of projects are in a rush with very strict timelines. And in these situations, also a lot of times we are able to offer a previous phase to the auditing phase. That is what we call pre-auditing, where we can help the projects to reach to a good point where they are reaching a minimal quality standard, and they are able to start a proper auditing process, okay? Another thing that is very important for us is to think about the design of the smart contract, okay? This is also a big issue, and sometimes we are not able to realize that there are big issues in the design before we start the audit. And when we start the audit, when we start to take a look at the design, we see there are some problems that solving them would require big refactorings of the code, okay? And in this case, when you need to do big refactorings of the code, you probably have to restart the auditing process. So sometimes we have to roll back and propose a pre-audit before the audit, and even give some time to the development team to do this refactoring and to start the process. I am illustrating this as an over-engineering example. I don't know if you know the Homer or el Homero móvil, okay? This is a very good example of something that is very over-engineered. Okay, we saw some Homers in the blockchain community, not only in Cardano but in other places also. Over-engineering is a big issue in software in general. What else? Maintainability. Okay, I don't have very much to say about this, but it's also it happens a lot of time that we are not able to find like vulnerabilities that are in the current version of the code, but we know that if you change a single thing, you will be probably introducing a very serious vulnerability, and it is not well documented or understood, or the code is not well modularized, or is not configurable enough to be robust to these possible changes. So sometimes there are big things, but again, as the definition of severity we have right now is, we cannot say this like a critical vulnerability, because the vulnerability does not exist in current version. So we usually resort to informational findings, but also in the private communication we are very like assertive about the importance of having this property of maintainability, because it's very risky if you do a very small modification, you think it is absolutely harmless, and then you are introducing a critical vulnerability you didn't have in your original audit report. Okay, another important aspect is functionality. It has to do actually with a part of the process that is very important, and that auditors, sometimes we are not able to speak a lot about it, because they have to do with the business use case and with the actual stakeholders of the product, okay? So as part of the blockchain community, we know about some business use cases very well. For instance, if we have to do the auditing of a liquidity pool, we understand very well the business rules for it, and we are even able to understand if there is some mismatch between what is the contract actually doing and what are users expecting to find there, okay? But some other times, there are like very particular business use cases we don't know about, and we are not able to understand the business entirely, okay? What we are able to do is, of course, to understand if there is a match or a compliance between the specification and the implementation. But sometimes, when we do that, we find that there is a compliance, and maybe the project launches, and then they realize that they misinterpreted a requirement, and the protocol is completely unusable, okay? So this is usually something that is on the side of the software process that is previous to auditing, but of course, we do our best to understand these aspects, and when we find something related to this, we usually report them to the customer, but we do not usually file findings for them. There is a particular case that is for the centralized aspect. Also, a lot of time we find that some things are more centralized than we expected, but the customer thinks that that is the behavior they are expecting. Okay, so we are not also able to file a finding for that kind of behavior because it is not strictly speaking a mismatch between the specification and the implementation. But what we do, because we feel like people that have access to this report should know, is that these centralized aspects exist. So sometimes for some project we have to add this particular section that is explaining these aspects. What else? Okay, this property I think is not something that is very general to find. I called it auditability. It is also related to understandability, but it has more lot to do with how easy it is to understand that you don't have a vulnerability in your code, okay? Or in other words, how easy is to reason about it, okay? For instance, I don't know, say a double satisfaction, for instance. Sometimes, like the number of reasoning steps you have to take to understand that it is not possible to have like two different inputs under the same address, and well, all the description you know about double satisfaction, you have to do a lot of reasoning steps to understand that you are not subject to this attack. It means that also you have a high risk in maintainability, and a single thing you change, you may be introducing double satisfaction in the next version of your software. I would also put in terms of formal proofs, maybe, if you have to prove that your software is not vulnerable, for instance, to a double satisfaction attack, how many steps you have to do in that proof to understand it. The other things related to auditability, well, one of the things I think is also important, that is like a bit difficult, is that usually validators are like conjunctions of predicates, okay? And when you want to allow the protocol to do something, you usually, what you have is the absence of a check, okay? You are not checking for one particular field, and sometimes as auditors we read all the code, we see that there is some check that is missing, and we are not very sure if we are finding a vulnerability or a bug, or if this is actually a feature and the protocol on purpose wants you to be free to choose whatever value you want for that particular field. So I think it is important, it's a practice that I don't see too much, that is to include in the documentation, or maybe inside the same code, in the under comments, what you are not checking and why you are not checking it, okay? So for instance, you are not checking the staking key of your output, okay? Why is that? You want to give control to the users of that staking key, or is it actually a vulnerability and you are forgetting to check for that field? Well, about efficiency, okay, we like also, we like coding, we like to program, and we like to write like nice programs, efficient programs, and sometimes we can't help it and end up proposing a lot of improvements on the side of optimization of protocols. Sometimes it's like an important aspect, like, I don't know, for instance, a batcher of a liquidity pool. You want to be able to process as many orders as possible, and you have to do like a very, very, very good job in optimization. Some other cases, it is not so important, and there is, I think, like sometimes a trade-off. Maybe sometimes also the projects work too hard on optimizing transactions that are not very important to be optimized. I would say, for instance, like, I don't know, some very important governance protocol that you are not making like a lot of transactions, just a few transactions, and it's more important for you if the community will be involved in taking decisions and voting and issuing these transactions. It is much more important to be able to have an understandable code than an optimized code, okay? And usually, at least for what I know, that is Haskell and Icon, is like you have to choose between one of the two, okay? If you want to go to a very understandable code, it will probably have some issues, or it will be optimizable for sure. If you want very optimal code, it will be difficult to be easily understood. Okay, after all this, maybe we can go back again to the definition of what is an audit. And this is like kind of a version I am working on. It's not like the definitive version. It was, okay, I think this is the version I had yesterday, okay? So it's very, very new. But some things I'm changing about the definition. First is to start to talk about a software product instead of talking only about code, okay? Understanding that a software product is not only code, but all the deliverables that are involved in the execution of a software development process, okay? So we are talking also about requirement specification, design documents, and all the deliverables of every step. What else? Well, talking about also compliance between implementation and specification that are both part of the software product, but also of external, like quality requirements and security standard that has to do with the blockchain and with software in general. Okay. Okay, just we are getting to the end of the talk. Some things that we usually experience when auditing is that, like, we live in an ideal world where we expect that every project that comes to us for an audit have completely finished their product, they tested it, they know it's the perfect product they want. They only want to see if there is some vulnerability before going to mainnet, okay? Well, it is usually not like that. I would say it is never like that. And this is a kind of average case we find where the project has almost completed the development. Okay, there may be some feature missing, some small feature, a couple of features, and they're like starting their testing phase, and they want to do at the same time the testing and the auditing because they're in a rush and they need to launch to mainnet in 2 weeks or in 1 month or something like that. Okay, so there is a particular issue with working like this. We work like this. We don't have a big trouble. It depends, of course, on the size of the features that are missing to be added to the source code. I think for me it is much more. This is acceptable. It is much more important to see that the project has done a good job in the previous steps of the software engineering process, like to have good documents describing the design and the requirements. Okay, if you have this is not a big trouble. Okay, there is a little trouble because we are auditing code that is getting modified. Okay, so there is a moving target we are aiming for, and there are some challenges there. Sometimes it also happens. It happens usually when these previous phases were not very well completed, that the team realizes that the small feature that was missing is actually a very big change they have to do, and there are moments where we have to do like a renegotiation of the audit. But well, this is just to as I said when I now announced the talk, it's a bit of therapy also for us to express these situations we usually have. Okay, and also to understand that we talk to customers, we push a lot for the usage of like a clearly defined software process, and I also think about how is software process used in other critical applications such as, I don't know, aerospatial industry, NASA, Department of Defense, and it is absolutely crazy the number of requirements and the complex these are all like diagrams of the processes, the software processes they have. At the different step you have to take to get your software approved and get into your aircraft or your satellite or whatever it is. I think if we want to give like a Cardano a protagonist in blockchain and like bring a lot of value to it, I think maybe this is too much. We will try to approach or take seriously the issue of using a software process. Okay, so that are more or less my conclusions. Auditing is not only about hunting bugs and vulnerabilities in the source code. I would say also like bugs and vulnerabilities are sometimes symptoms of deeper problems. Okay, and it is also, so we can point the bugs and vulnerabilities, but it's much better to understand what is the deeper problem and try to fix it. And of course, what I was saying, we must not expect an audit to be a replacement for a lot of steps you must do when you develop software. What else? Well, yes, our goals at TXPipe. We're working a lot in maturing our auditing process. This slide has to do with this. We are also trying to make our process as standardized. Okay, we are working on a lot of guidelines and documentation, but also tooling to have a very standard process, and it's something also we want to share at some moment with the community. That's it, more or less. Just some extra slides with some things that we are working on. About tooling, we have Nico working on this VS Code plugin that helps us to do our auditing job, where we can take notes and share them with the other auditors. I think it will be very, very useful. And this other work that is very interesting for us is Blaster, that we are starting to collaborate also, and we are interested also in starting to apply this kind of approaches, formal approaches to auditing. Okay, that's it. Some acknowledgements to all the projects that trusted on us. A lot of people that also supported us and helped us. We started 3 years ago, and we were like beginners in the auditing world, and we learned a lot, and that's thanks to a lot of people that helped us with that. I would say Lucas, Casey, also Pai Lanningham, I think. The university, because a lot of people that work with us comes from the university. Well, that's it. Thank you.